think it's done.
Yeah, it should be,
Sweet.
hopefully. All right, you'll have to put it back in that freezer.
I can do that.
Okay. All right, this is Isaac. He's gonna present his spelunking case.
Okay, yeah. So, like she said, I'm Isaac. I'm a chemistry major here at the University of Wyoming. And this is the work I've done thus far on my Disto X2 waterproof case. So you guys probably don't understand most of that. Don't worry about it. We'll get to there. So first I want to get into how I got into caving really quick, because like it's, you know, just to show the conception, like the different levels of how I got to here. And years ago, me and my dad, about 10 years ago, went to Tongue River Cave, which is the entrance is that picture over there. That's one of the most popular caves in Wyoming. It's a really beautiful cave. And it's just a really fun time for any skill level. And I just like always remembered that and had fun with it. And so then here, like 4 years ago, this book, Caves of Wyoming, which is from around, I think it was written in like 1967 is when it was published. It was actually published by a grotto based out of the University of Wyoming, which doesn't exist anymore. But it's just like this really kind of quirky, cool book that has just like, they show like everything, even like these little like 10-foot caves out in the middle of nowhere. They went into a lot of effort. And so I kind of had read that book cover to cover and sat on it for a couple of years. And then this last summer, you know, just out of, I guess, COVID boredom, I finally broke it open again. I'm like, you know what, this is the summer I'm going to actually go out, start checking out some of these caves and going. Very quickly, I ended up joining the National Speleological Society, the Pahasapa Grotto, and the Northern Rocky Mountain Grotto. The National Speleological Society is like the big caver organization, like worldwide. And there's around, I think around 10,000 members, maybe 12,000, somewhere like that. Pahasapa Grotto is based out of South Dakota. They are the ones responsible for mapping Jewel and Wind Cave. They do, you know, vast majority of that work. And then Northern Rocky Mountain Grotto is based out of Montana. And so you'll notice that there aren't any grottos in Wyoming, because I think there's only around a dozen active cavers in Wyoming. And so I just have kind of joined all the different grottos in surrounding states that sometimes do work in Wyoming. And by the way, grotto is basically just like a local club. It's a subchapter of the NSS. So yeah, and I've been having an absolute blast, and I feel extremely lucky. There's so much experience behind the people in both of these grottos that, and just the amount of like, I guess, guidance that I get is just absolutely insane. So if anybody is at all interested in caving, this is the way to go about it. Go join a grotto. Even if you just want to do recreational caving, they'll be able to get you into really cool caves that are more technical or that are on private land that you won't have access otherwise. So, all right. And then, so with that, most of the caving that I do at this point is cave survey, and which is just another word for mapping caves. And so I thought, and I always get people that come and ask why I survey caves. I think because it is straight up work. We actually usually count as like volunteer hours, and cavers are like by far the highest volunteer hour earning group of like for any of like the national parks and stuff, because it's just so labor intensive compared to like maintaining trails or picking up trash, anything like that. So, but I would say like the main reason I do it, like the first one is, and ultimately it's just for fun. It really is super fun, and it's like fun in a different sense. It's not like kind of like that like mountain biking adrenaline filled like instant gratification. I more like compare it to like Minecraft, where like you're kind of like spend like hours and hours and hours building this thing, and there's parts of it that just straight up suck and it's really monotonous, but then when you get to like the end product, it's just incredibly satisfying. So and then the other reasons are caves are really kind of one of the last places that we don't know anything about. right? So as far as like obviously on the surface of the earth, like we have GPS for everything. And so we just know all that, all that there is to know. Even like there's like some mountaintops that we haven't been to, but we have pictures, we know exactly what's there, right? And that also applies to the vast majority of the ocean. Like even though we might not have actually physically gone down there, we know what's there. And so there's nothing that's not surprising. So I mean, really like caves and then outer space are like the only places that like we just have absolutely no clue. And there's just an infinite possibility of stuff that could be out there and stuff for us to learn. And so I think it's just really cool to be like part of that. And then another thing is like, I can say with confidence that I have seen things that no other living being has ever seen before, right? I mean, the only things that live in these caves are like microbacteria and stuff. So and I think that's just kind of wild to think about that. Like I'm the first person in the existence of the cave to walk into this room. That's just, a really cool feeling. And then one other thing I should have put on here and forgot to was that without cave survey, other cave research doesn't happen. And so it's really important that, for instance, if you want to go and do tests on the microbacteria in like a underground lake, if you don't know that that lake exists, you can't go do those tests. And so and then obviously to do further cave survey and stuff, so that's also very important. And then next up, I just kind of want to give a really brief like too long didn't read on how to survey caves. So in general, we need 3 like magic numbers in order to make the cave maps, and those are distance, azimuth, and inclination. So the distance is on, all the way, I guess that's your left. And it's simply how far is it from point A to point B. All right. And those points are, we have survey stations, which is just a spot that we denote on a wall or floor or ceiling. We usually use flagging tape. Sometimes we have like these little markers that we drill in. It depends on the cave and, the ownership with all that. And then azimuth is which direction is point A to point B in relation to north, south, east, west. So this is like probably the hardest thing to get as far like, because I mean, there's a lot of instruments that exist that do distance and inclination that are not that expensive. All right. There are very, very few. I mean, basically the disto is the only thing that does azimuth in a accurate way. The way that they used to get these measurements before the disto existed is like for distance, you would literally like use a massive tape measure, right? And then for azimuth, you would, for distance, you'd use the tape measure. For azimuth, they had like these compasses that you would look through. But like, obviously those are much more time consuming and not nearly as accurate as, electronic methods, especially with the azimuth, because like most headlamps are magnetic. And so when you're holding the compass up like that, I mean, you're altering it. One of the resurvey projects I'm part of, one of the main lines of it is like 20 degrees, like the old map is like 20 degrees off, because, and so this is like, this is where the disto comes in. But really quick, so then this is just a picture of some of the data from one of the projects I've done. And so I actually drew this, which is why it's really bad. But you can see the triangles there are the survey stations. And then over there, I have the data. And so you can see we write down, distance, azimuth, inclination. And so then for the distance, right, when you're making the map, you just have a ruler and it's just, 20 foot to an inch. And so, that first one's like 40 feet. So then you measure 2 inches and then you just draw the line. And then we use just like protractor, and then you can do the azimuth between stations. So that's how it works. Some maps like, and obviously this is like a very rough, so then afterwards cartographer will go through and clean it up and make it look nice. And every now and then on a final map, you'll see they'll still have the survey stations and stuff. So if you ever run across that on a cave map or see it, now you know what it is. That's just, the points that they were shooting between. And then those other numbers, L rods, left, right, up, down. Those are just kind of, they're not nearly as accurate as the other ones. We just kind of eyeball them and they're accurate within a foot. So, and then that's just, yeah, how you know. So like how far is it to the top of the ceiling at the station, to the left of the station. And one of the LROD's numbers will always be 0. So because obviously the station has to be connected to a wall or floor of some sort. So and then that brings us to the Disto X2. So the Disto X2 gets us all 3 of these magic numbers very, very easily, right? All I gotta do, let's say this corner is my station and I'm shooting to that corner of the table right there. That's a different station. And there we go, 10.58 feet, and it's 195.7 degrees. That's the azimuth, and negative 1.5 degrees is the inclination. Just like that, right? We have all the numbers we need. You write it in the notebook. All right, the sketcher can do the map. So this really is like makes mapping caves exponentially both faster and more accurate than the previous methods. And so the downsides, which there aren't like with the actual unit, are it's $700, and even if you have $700, it's not like you can just go out and buy this thing. So it's in a so the Disto body, so the X310 or the E7400X is actually discontinued, and so tracking down one of those can be kind of difficult sometimes. And then the upgrade board that's in these, which allows us to both measure the azimuth as well as connect to Bluetooth. So then there's actually ways that you can sketch on like an iPad and stuff. Those upgrade boards were never like an officially thing. Someone basically came, designed them. It was like one of the engineers at Leica, you know, off on his own. And then there's only a handful of people that make the upgrade boards. And so I was actually like pretty fortunate that I was able to track down one of those people, and he happened to have some made when I needed one. So it's very, very difficult to get these things, and there's not a lot of them out there. And so they're, I mean, for me, this is more expensive than all my other like caving gear I generally use combined. So it's like obviously very valuable. That said, they are reasonably durable. As you can see, they have the IP65 rating, which means that they're dust resistant, and they can also like be sprayed with water and they'll be okay. And then they are they good for drop tests up to 2 meters, 6 feet. So I have actually heard of them taking much like worse drops than that, because this black is like all rubber, and so they're actually like, you know, pretty solid. But still, when you have something that's like, you know, this valuable, that IPX65 is a scary number when there's a lot of caves. One of the caves in Wyoming, Great Expectations, has a section that needs to be surveyed where the ceilings are like 6 inches to a couple feet, and there's running water going through the whole thing. And so having that IPX65 is just a really scary number. And when it's something, you know, this valuable. And also, if you have the unit break while you're surveying, then that's the end of the survey. And so it would really, really suck to go in. I mean, some of the times we're doing, you know, 10 hours, 19 hours plus just to get to the point where we're surveying. And that would all be wasted time if the unit broke. And so it's really important that this is as reliable as humanly possible. And so then this kind of goes to like, I guess, the inspiration for the case. So I saw this is another waterproof case when I was on a horse thief resurvey trip. And my very first thought when I saw it was, first of all, it's really cool because the convenience of this is so nice, because right now what we're doing is we have our Pelican case, right? And so then when we have to go survey, we have to stop, open up a Pelican case, use it. All right. And then a lot of times we're just going like 50 feet. And so we never know whether to like put it back in the Pelican case, just keep it out. And then what do you do with the Pelican case? Because it sucks to put it in your bag and then take it out and back again. And so first of all, like just having the case like on the unit is just so much more convenient. It just simplifies all that. And also should save wear on the disto, because you're not traveling with exposed disto ever, right? But then the second thought I had as soon as I saw that, I was like, that is not at all how I would go about that. It's just, to me, there's just way too many parts here. As for, you know, my preferences, I really value simplicity. And so, and when you're like assembling it, you have to like do it like a car tire where you do the star thing. And if you don't get it perfect, then you don't have a good seal. which to be fair doesn't matter that much. But and again, I don't want to, knock this too much. I still have a lot of respect for this case. It's just a very different approach to how I wanted to go about it. And so like as soon as I saw this, I basically had this idea pop into my head. Basically just have one cap, right? And then you unscrew it, you slide the thing in, you screw it back on, and then you're good to go. And so that's just kind of, what I wanted. And from there, I just kind of set out doing it. So luckily I learned some inventor in high school. And so I just started modeling. And but before I get into that, I want to get into like the expectations that I want for my case. Obviously IPX68. I really just want it to be fully waterproof so that no matter what, I can dunk it underwater and not be worried at all. I also want it to be much, much better for drop tests. 15 feet at the very minimum. I would really like this number to be more like 30 feet, if like, something like that. And also I wanted to, in general, keep it as simple as possible and keep it as light as possible. Obviously, because we really don't have a lot of extra room in our packs and extra weight that we can be taking in. So, and then I wanted to go for a completely toolless design so that if, for whatever reason you had to take it apart inside the cave, it could be very easily done. Not only did this end up being toolless, but I can actually do it when I have gloves on, which is, really nice. And one other thing is it's really important to me that it has one-handed operation, because sometimes we're like, reaching up to really weird spots to get a shot, like reaching up like this. And so you really want it to be where you don't have to have two hands. And like sometimes you're in a tight crawl. And so getting both hands. So that's another, part of why I want it a bit smaller. And so, yeah, then we kind of cut into inventor. And I just kind of went crazy. I did most of these in a time span of like 2.5 weeks. So a lot of work. And I got to where I was knocking these out in like 45 minutes, but I think it's just kind of cool to see just the very slight changes as I, got better and better. Like from one of the very first changes I made is you can see way over there, I originally had those like sharp corners, but then I switched to a rounded corner. And that is so that I could get a better seal when I glue it on, when I glue the vinyl screen on. And then also I, changed the threads quite a bit because I have been messing with the tolerances. I threw on a logo, and then, I kind of kept on going back and forth between how I wanted to design the lanyard mount. And I ended up, going with this, and I think it seems really rigid in person. And a lot of these cases actually never existed physically. As far as the ones that did, though, we have all of these, and there's still probably 6 other cases that I've printed out that aren't even included here. So I have done, a lot of work. And not only has the cases changed, but the lids design has also changed quite a bit. So you can see for those first 4 lids, I originally had a design where you had the plexiglass lens just sit right, on top of the lid. And then I decided to have it recessed, and that just made it where I could really make it shorter, make this section much shorter than if I had, the plexiglass and then the lid. And it just, saves some room, and it also kind of pops in and out pretty satisfyingly. So I like that. And it's definitely much more consistent. So yeah, and then another thing I did is you can barely see it in this picture, but originally I had this bottom O-ring right here. And so the idea was the O-ring would seal along the inside right here. But then I decided that was dumb, and I made it so it just seals against the lip of the lid, which just makes more sense and is much more mechanically easy to do and reliable. So, but I have had so many issues getting this to work. Like anyone that has just especially a project that's relatively big and doesn't have, just a list of problems is just inhuman. So one of the first big things, and this almost caused me to just, ditch the project instantly, was I had trouble finding the adhesive to glue the vinyl to the plastic. I tried 3 different ones. And then I finally tried the obvious one, which is just a vinyl, plastic adhesive from Walmart. and it works like perfectly. So that's what I've been using ever since. But yeah, I tried like marine epoxies and stuff, and none of them worked. And then yeah, this one works great. And so I found that like in the nick of time, and because I was about to give up. I had so many software issues. One of the things is like when I was here, originally they had me trying to use Cura, and I was doing it on the Prushas. I spent like 6 hours just troubleshooting back and forth, and I finally just downloaded the Prusha slicer. All right, and it just worked flawlessly. And so, yeah, there's that one that's pretty relevant here. And then, oh, I also had this one weird thing where when I was exporting from Inventor, if I didn't have the file set to high resolution, it would like make the all the circles like almost like octagonal, which is just annoying. And another thing is like, it took me a while. So Inventor, when you make threads, doesn't actually model the threads. And so it just like puts on this like fake picture of threads. And then I finally found a program though that will take the Inventor information and just automatically make the threads. And so like I kept on trying to print it, and then it wouldn't make threads, and I was just getting mad. But then I got that. Printing issues, obviously. So this is like not an easy print. I just print it just like this. And so it took quite a while, especially with getting the adhesion good on the bottom here, because it really wants to, just move. And yeah, there definitely have been a lot of failed prints, but I'm to the point now that I've been like switching between. I've printed in like 4 different materials now, and I just like know the model so well that I can print with something new, try new material. Like when I switched to PTG, which has like historically bad overhanging problems, like I still I got the settings dialed in where now it does this overhang completely fine. So and then the obviously tolerance fine tuning just took ages, especially getting the seals good. And I think that's still something I'm going to alter just slightly. It works, but I want it to work better. And then the big ones were I kept on having leaking issues and durability issues. And to me, those are like the 2 big things that are unacceptable. And once again, similar to the adhesive, I was like very close to just scrapping the project. But then and one thing is like whenever I get into a hobby, I just YouTube the crap out of it. And so when I got back into this, I started watching 3D printing YouTube videos, and then this one over there popped up on my feed about remelting 3D prints with salt. And the idea is you pack it full of salt, and then you stick it in the oven, and it completely melts into one solid piece. And then you kind of get rid of all of the negatives of FDM printing, because now there's no more layers. And so that one over there is by CNC Kitchen. He does a lot of stuff. And then this one is, oh, I did not mean to do that. Yeah, this one over here is by this YouTube account called Free Spirit One. And so this is the guy that like originally came up with it. And then CNC Kitchen is like, some materials engineer background. And so he went and like did rigorous testing of it and found that it was like 90% as good as like injection molded parts. And so I was like, that seems really, really cool. But the problem is getting salt that's fine enough for this to work is really difficult. And so like one of the issues, and like the finest ground you can get salt is popcorn salt. And even that is still too big of chunks for it to work well with this. And so like this dude, when he did it, he ended up like burning through a coffee grinder, just trying to make enough salt to do this. And then CNC's was like, you can see kind of on the outside of his salt remelting one, like it's just not consistent at all. There's lots of like pores and stuff. And so for me, like I needed to be very precise because like I need to replicate these threads where they still function and work, right? And so I kind of thought, and I was like, okay, well, what if there's something besides salt that could work? And then I remembered that I had these blocks of rock climbing chalk that were sold in blocks. And so I'm like, okay, so rock climbing chalk clearly is able to be packed down. I looked up the melting temperature is like 900 degrees Celsius. It's like, that's fine. And so sure enough, and then you can also buy it in big quantities from Amazon for like, $25. And so that's what I did. And then again, I just kind of took the same concept from the salt remelting, and I did it with chalk. And so generally this kind of just shows the process of how to do it. you get some sort of a pot, and then you pack it down a bottom layer. It doesn't have to be very thick, and then you need to pack the print. Like, so for this, because of the cavity, it's really important that you like pack the inside of it, and that's kind of hard. So I have to like do this, pack, and then hold this side, pack, back and forth until I have it like really solid. And then you have to put it in, pack all the way around the sides of the print, and then you need like something that you can like push down on like the whole block of stuff, and so that you can get it really, really solid. Otherwise it just falls apart and it's a mess. And then also you'll notice that there's this thing coming out of it. That is a meat thermometer. And this is so that I can monitor the temperature on the inside, because it does take a long time for it to heat up to the right heat. And so having that meat thermometer, then I know exactly what it's at. And if it's overheated, then it will actually like cause these chemical reactions with the plastics, and it won't work well at all. And you just kind of defeat the purpose. So yeah, that's just kind of generally how you do it. If anyone wants to try it, I highly recommend it because it makes parts insanely strong from FDM 3D printing. And these are some of the results that I did after I did different impact tests. So this is with high impact polystyrene hips. This is the same stuff that red solo cups are made out of. But you can see the one on the right is just normal 3D printing, and it broke very, very quickly. You know, I just dropped it like this, and after the 5th one, it just broke when I had the weight that simulated the disto. And then the one on the right, like I smashed and stomped on it, and like, so it took so much more effort. And you can tell that it worked because this one broke perfectly level along the layer lines of the 3D print, whereas this one broke just randomly because it doesn't have any reason to break in any specific pattern, and it's just one, you know, solid chunk. And so here again, you can kind of see you know, how it just broke flat right along the layer lines. And one other little thing is there's like a hole here. And earlier I mentioned one of the issues I was still having was with waterproof issues. And that's because the water was getting in between the layers of the print, and then it was like, you know, following these holes. So if there's any two like microscopic cracks on the outside and the inside of the case, eventually water could get in. And I mean, in theory, I could just, you know, make the case way thicker and get it to work. And so then you're just lowering the chances of water being able to find its way through. But I really didn't want to make it any bigger than it absolutely had to be. So yeah, but you can just see there, and this one's just kind of cracked completely randomly. Got lucky that it broke like that. And the other insane thing about the chalk, so this is the remelted one, and it remelted so precisely and accurately that it actually replicated the layer lines from the 3D printing, which is just kind of mind-blowing. And especially when you look at like CNC Kitchen and his results, where his had these like big pores and holes because his grains were all inaccurate, but the chalk is just so fine that it just perfectly does everything. So really cool. And once again, this kind of just shows how the inside is really solid, especially this picture shows it really well. And you can see there how there's still the layer lines, but they're just on, you know, the very, very edge, the very, very outside. As soon as you get inside, it's, you know, just rock solid. And so, yeah, that kind of leads me to where I'm at right now. This is my, you know, current main prototype. And I actually have that. So this one is not remelted and this one is. They're both supposed to be clear PETG. And so you can see the remelted one has this like really cool, like translucent look to it. You can kind of see the disto in the picture, like you can still see through it. And so it's also like so much nicer to work with these clear filaments because light gets in there really easily. So I can just see what I'm doing, you know, when I'm installing the vinyl screen protector and whatnot. So, and then one thing that I really like about this design with the screen protector being, which is just plexiglass, is that there's like this little notch, because every now and then, like when you're surveying, you'll like accidentally hit the wrong button, where now I can just like slide my thumb into the notch and that just lines it up perfectly with the button and you can very easily find it. So I'm really happy with that. And so, yeah, that's kind of where I'm at. And this kind of is, you know, some more pictures. So that shows, you know, the lid design that I'm at. So, you know, the two O-rings and the plexiglass. And so that O-ring seals against the lens, and the other seals against the case, and should stop all water from getting in. And that is just more to kind of to show the size against the Pelican 1015 case, which is currently the standard what the vast majority of people are using to store these things and to transport these things in. So, and as you can see, it's actually like a bit thinner. So like the only part that's in any way bigger than the Pelican case is this, like the round part on the front. And even that is only slightly bigger around than like a Pelican case is. So it's, really, I think it's a pretty reasonable size. It's not anything too crazy. So, and then next, just kind of getting into what I've still got to do, because I'm definitely not done. I need to just do more PETG stuff. So you saw with like the hips, I completely destroyed it. I'm going to be doing the exact same thing to these cases, and just to kind of make sure that this is as good as I think it is. And then I just have some very small design changes I'm going to do. Very minor, nothing huge. And then like one thing is I haven't used these underground at all yet. So I'm kind of to the point where I'm really just excited to get these actually used and to see, because I mean, right now, like, I guess it looks fantastic on paper in here, but until it's actually practically being utilized, that means nothing. And then the remelting and then like gluing on the vinyl screen, I'm still working on getting that just perfect, and trying to make the vinyl look as clean as possible when it's glued on, and trying to just nail in the temperatures for the remelting and the process for packing it down. It's just, takes some work. And one thing I want to do is I want to try like dipping the whole thing in plastic dip, so you have like a big rubberized coating on the outside. I mean, it has some disadvantages, but I think overall it'd be pretty cool. And then I still need to like, remelt these lids. I just didn't have time to do that, but they shouldn't be hard. They're much simpler, they're much simpler than the case is. And if I can remelt this, I can remelt the lids. So, yeah, and I guess that's the end. So I guess kind of when I got into caving, 3 months ago or so, I never really like, I never would have thought that I would, be developing, a like 3D printing procedure. And so I guess if I just want to encourage you guys, go try some new stuff, because you really don't know where it will take you. And where it will lead, because like this is just like I never would have thought that I'd be here with this. So yeah. That's about all I had. Any questions?
Talking about where it will take you, do you have plans of commercializing?
Yeah, so I do have a 3D printer at home that I bought. I'm still very far away from that. I need to get to where this is really solid. But I'll never be making these on a big scale, because there's only like, my best guess, maybe a couple thousand of these things in existence. And so it's in a very, very niche market. But yeah, I like in the future, hopefully yes. But I'm still far away from that. I need to get it to where it has hours underground, and I know what other people think of it, and I have some feedback before I would ever sell it. So yeah. Sorry.
I have 2 questions.
Okay.
Does the plexiglass mess with the sensor?
It doesn't. So yeah, I did tests up to like 150 feet, because they shoot pretty far, which is like a very, very like long measurement. A lot of like places have like 50-foot limits, and yeah, it's like the exact same reading. It doesn't. I'm not completely sure how it works, but it's almost the exact same. So this one is like 10.5 feet around. I think it was like 10.41. I can do it with the plexiglass, and yeah, it'll be the same thing. Laser. Yeah, 10.39. That's, I think it was like 10.41. It's like, honestly, this little lip here on the back of the case, because that's actually how it measures, is from the back of the device. That's going to have a bigger impact than the plexiglass from the laser. And it's still very, very accurate. And you can actually go in the software of this thing and have it account for this small section in the back of the case. So it's literally changes it by 0.01 feet. So it's, and you have to round up to get there. It's technically like 0.006 feet, like when I ran the calculation. So it doesn't. And what was your other question?
Do you plan on making like little shoulder, little wrist straps? So like,
Yeah. So that's what this is a lanyard mount. And I meant to run to Ace to get, one of the strings to do it, but I just kind of forgot to. I was a bit low on time. But yeah, and yeah, that's what this is for. It's just, kind of like a Wii remote. So yeah, and hopefully, that should also limit how often people drop these things. So yeah.
You mentioned earlier that that most of these were discontinued. Is a function of design, or if it was because it's popular, or?
I think because it wasn't very popular. I think we're literally like the only people that use these a lot. Because most people use like, bigger, bulkier ones that are, even more accurate and stuff. But because I mean, most of these are being used in things like, like construction type stuff. So it's not really like this is, taking it and modifying it to fit our needs. So very, very, very few people besides cavers care about these. So, and at this point, there's cheaper things that can do the exact same thing. And there's other, like, ones that cost the same as this that are, much more accurate for other applications. So, yeah.
When you were talking about your melting of the chalk.
Yeah.
For this, and you said it needed to reach a certain temperature. What kind of temperature range, and then how long did you need to leave it at?
Yeah, so you just need it to just barely get to the temperature basically. And I tend to go a little bit lower than printing temperatures. Once you get up to printing temperature, it will actually be too hot too long. And so you just want to, I generally am going for like 20 degrees Fahrenheit below the lowest recommended printing temperature. And as soon as it gets there, then I, kind of stop it and start cooling it off.
And
So
the theory behind that is just that will basically help that melt those layers together to make it more solid.
yeah, the layers literally don't exist.
Yeah.
Like if you chop this in half, you will not see layers on the inside.
Okay.
The only layers you see are on the very outside. So yeah, it completely changes the structure. And because I mean,
so we couldn't do that in that little toaster oven, could we?
I doubt it. How hot does it get?
I don't know.
It depends how yeah, because so like for PETG and PLA you need around 4, like this was like 420 degrees
Okay.
Fahrenheit, so it needs to get pretty dang hot. And then also like the oven I did this in went up to 550, and so then I just used the barbecue thermometer to stop it. And then also like obviously that's not going to be big enough to hold the container that you need to do this, so you'd be able to do smaller things. But I mean, if that got up to over 400 degrees, in theory you could do it.
Okay.
And also it doesn't ruin pots, so like the pot is still totally good. You just dump it out and you can still use it for normal cooking. So
What about your chalk? What happens to the chalk?
the chalk you can reuse an infinite amount of times. I mean, I lose a little bit of it because it's just very messy. Like it's impossible to deal with that much chalk without, some spilling out the sides and
So, like,
getting
you go
everywhere.
climbing with the chalk later.
Oh yeah, totally. Yeah. I mean, I just have it dedicated for this, but yeah, the chalk just stays the exact same. Same with salt, and yeah, as long, and I mean, in theory, like any powder that packs together and holds its shape and has, a melting temperature that's significantly higher than a printing temperature should be able to do it. Yeah, it shouldn't matter too much. I guess the only thing you should be worried about is like expansion with the material and altering the shape. So, but yeah, no chalk, obviously it works. So, but yeah, I can go ahead and pass these around if you guys want to see if there's some difference between the melted one. Exact same material as well.
how much film? Because I know you have to like do 100%.
Yep. So these are a little over 100 grams. Well, I think around 120 grams to do the case. And I can't remember how much the caps are. They're not as much. I could do like 3 caps and less than the amount of filament it takes to do the case. Yeah, it's not terrible. And the printing time for the case is approximately 18 hours. It depends what the filament is. It'll alter by like an hour, but yeah, it's so. Yeah.
Also, how much does that chalk cost?
Yeah, the chalk is only like you can get 2 pounds of it for it's like $25 or $26 right off on Amazon Prime.
You
So
have to like crush it up.
no, it's already good. Yeah, no, the chalk's already good. That's like the advantage compared to the salt, is the salt takes a lot of processing once you get it. And the other scary thing about the salt is a lot of salts have anti-caking agents, which prevent it from doing the exact thing I want to do. And so that's one of the other reasons I was scared to go with salt, because, you know, it'd be a lot of work, you know, just to get it to the right size. It wouldn't be as consistent. And then even if I did all that, it still might have some anti-caking agent in it that I didn't know about, that wasn't advertised. And then it just wouldn't work at all. So that's why I went with chalk. And it's pretty happy that it actually, you know.
Yeah, and Isaac was bringing in his own filament to print the recipes.
Yeah.
Yeah.
And actually all of the cases in this picture were printed here. So yeah, the red is just a generic PLA. The green is a like a PLA Max. This is supposed to be a more durable PLA, but and then yeah, the white is PETG. So
And that final one's piece.
yeah, those are PETG. So, and I've been pretty happy with PETG so far. Of the 3 materials or I guess depending on whether you count the green as PLA or not, like of all the materials I've tested, PETG so far is appearing to be the most promising. HIPS is also really nice because it's very, very light. It's not dense at all compared to the other ones. So no, I think PETG is going to be stronger than HIPS. Yeah. And the other nice thing about PETG and HIPS is they're both recyclable. So with where PLA isn't. So
And feel it's also brittle.
is also what?
Brittle.
Yeah, it's very brittle. It prints nicely though. But and I'm sure, like, you know, the durability would probably be good enough if you remelted the PLA. But
For my application, it's certainly.
yeah, it's, you know, very extreme for sure. So
Thank you.
yeah, thank you. Is there anything else I need to do up here, or?
Yeah, I know. I want to check that too.
No, I'm just going to use that to test things. This one, because it has voltage. I put stuff over it, so that should be. But I don't.
Oh, this is actually, no, this is
Pressure and screw in it. It's this.